Hey everybody, welcome back. Well, a couple of you have asked how do I show the local horizon in when I show images from Stellarium or show videos in Stellarium, and so I thought I would go ahead and show the simple thing that I do to show my horizon. I don't go to the extremes that some people do who go to a lot of effort to make a really cool horizon showing their own backyard as a picture. Instead, I just want a simple line, and I don't want it to block the stars beneath the line, and because I want to see what is on the verge of coming up, so to speak. So I'll show you what I go through, a couple of versions on how to make a very simple horizon. Also, there are a couple of other hints that I wanted to share with you for those of you who use Stellarium for image session planning. I know a lot of you use Nina, for example, and other resources. For those, Nina is a great image session planning and framing tool. Right now, at least in its current state, it doesn't show the view from the auto guider, from the off-axis guider, and that is something that Stellarium does do, and I find to be very useful, particularly when imaging with a long focal length system where finding a guide star might be more difficult than otherwise. So anyway, let's take a look at Stellarium and some of the things we can do to help us out during our image session planning. Okay, here we are in Stellarium. I have the pause button pressed here so the time will not be advancing. I think that's something useful when you're laying out your images or trying to find the perfect aim spot. You don't want this thing moving on you, so it's often good to find the time of night when the target that you're interested in is up and available, and then just press the what was the play button, press it to convert it to a pause button, and then things don't move on you, so that's useful. This cyan line here is my horizon as it wraps around in 360 degrees. I have a bit of blockage. The highest blockage I have is to the southeast, and then it swings around and finally comes back around. This is the fence line to where I'm close to the fence here. This little bump up here is essentially a very simplistic version of a small tree on the neighbor's side of the fence that pokes up. But anyway, this is the horizon line. So how do we get this thing in there? Well, I actually put this in a video sometime back about how I came up with my horizon. And so instead of just sending you off to that video and telling you to watch that portion of the video, I'm just going to cut that portion of the video out and put it in here. So let's take a look at that. This is the beginning of the horizon, and this is the worst spot for me in the horizon. I found this app, Diopter App, for the Android. It's free. It's a good app. There are other ways of doing this. Certainly I've used Sky Safari on the iPad, which you can hold up and point towards a location, identify the azimuth and elevation. What is neat about the Diopter app is that you're taking a picture with your cell phone, so it's recording right there in the view what the azimuth is and what the corresponding altitude is. And that's not something you get with the iPad and the Sky Safari app I was using. But you can see I'm sitting in a chair in the backyard looking up behind me at the house. So this is essentially the view my telescope would have. And at this particular azimuth of 143 degrees, I can't see anything below about 37 degrees in altitude. Now, if I scan over a little bit to the right, continuing on around the circle, at 168 degrees, I can see a little bit better off at about 29 degrees. And then if I continue on down, now I'm looking at the houses down the street from me, and at 217 degrees azimuth, I'm basically at a 8 degrees altitude limit, which is fine. You wouldn't want to image below that anyway. And then, of course, as we come on around from 217 back to the north, we get along my fence, both here and the fence coming back to the north, and it's all at a pretty low altitude. I don't have many obstructions to the north. It's mostly to the south that I have the obstructions. But what is nice about this app is you can go ahead and snap these pictures, making the full circle around, and then you come up with a table of azimuth and altitude angles that you just copy in from these various numbers here in the pictures. And now you have a table that's totally compatible with, for example, Carte du Ciel. This line here delineating the black sky with this brown region here is that line that we just looked at, the altitude azimuth line. And Carte du Ciel is just coloring this in with a user-defined color. So that very simple collection of numbers, the azimuth and the altitude, were numbers I collected using the Diopter app, and it's the simplest file it could possibly be, just a simple text file, and that's what we'll use here. And by the way, there's a good resource for this. Let's look over this web page that you can take a look at for a resource going forward. So this is the stellarium.sourceforge.net/wiki/index.php/customizing_landscapes webpage. And there are a variety of different types of landscapes. There's the polygonal method, which is the simplest. We'll look at that. There's a fisheye, a spherical. We'll also look at a simple version of the spherical method. And then there's the multiple image method. Any of these can be used depending on how complicated you want to get with your landscape. And there's a nice little discussion for each one, the nature of a file. Every one of these will come with what's called a landscape.ini file. It's a simple text file. And inside the file will be certain parameters, and then an equal sign, and then the parameter you type in. Everything on the left side has to be written exactly as written here, although not all of these parameters are required. But you can read through the file here, through this web page here, and find out what each parameter here does. And then, for example, when you record your horizon in the file format that you saw earlier in the video, you would just type that file name here, and it would be ready to use going forward. When you get a chance, check in on the Stellarium Wiki website under the Customizing Landscapes portion, and there's probably some useful information in there. All right, let's go back to Stellarium. So the simplest form of the horizon is the polygonal form, and you go into landscape, and in my case, you already have in your installation, and I'll show you where this is, the Geneva landscape. And here, if we take this Geneva, notice that title, let's go into installation folder where Stellarium is on your computer. So on my computer, I have it under the D drive under programs, and then I have Stellarium installed. I go into Stellarium, and then under here is a folder called landscapes, and there are a number of landscape folders here of which you can add. So I've added one called backyard, I've added one called home. These are both ones that I put in. You can put in your own folder. But if you look in the Geneva file, there is a very simple landscape.ini file, and open this up with a text editor, and you'll see that the nature of this is the type is polygonal, so that's that simplest form of polygon. The horizon for the Geneva landscape is horizon_geneva.text. In your case, you'll name yours backyard.text or whatever you want to call it, and that's what you would put in here. You can give the ground color some form of color. This is red, green, and blue from 0 to 1. So a 0 here would make it a 0 in each one of these spots would make this black. A 1 in each one of these spots would make it white. There's a horizon line color that you can put in, different color, of course. There's also a location section. I put this in. I don't care about the light pollution, atmospheric 16. I don't put in any of that. I do put in the planet Earth, the latitude, longitude, altitude, and time zone, just for the heck of it. But I don't even think this is required, although it's probably a good idea to put that in there. But this is what we're looking for. We're looking for the horizon file that you record, whatever way you decide to record it, and you're looking to create a landscape.ini file. And for you, if you don't have, you haven't done this already, then go to the Geneva directory, maybe just copy that directory to your own version of the directory, change these values as you see fit, change this number to the horizon azimuth altitude file that you create, and you'll be about 90% of the way there. Now, in my case, if I go to my version of the Geneva landscape, the polygonal landscape file, my backyard version of the file, and you can see here what's happened is it's filling in the area below the line is being filled in with black. So I can't see any stars below that. Now, that's okay. I mean, after all, the horizon that we're putting in is blocking our view to those stars. But for me, I kind of like, I have a minimalist approach, and I just want a line, and I'm perfectly okay seeing the stars below it because I want to see when some target that I'm waiting for is about to pass over the edge of my horizon. So if you want to do that, things get a little bit more complicated. In this case, we need a file called a PNG file, which represents the landscape. Now this PNG file could be your own landscape of stitched together images taken with a camera, aligned so that it has a common horizon from picture to picture, and it covers a certain angular range from, say, 40 degrees below to 40 degrees above the horizon. Those are all parameters you would enter in. You can do that. There are resources on the web for figuring how to do that. Probably some good YouTube videos on that as well. But if you just want to get to something simple, and let's go back to my version of that, which is the custom. Now you'll see what happens. Now I can see the stars, but I'm still retaining the line. I don't know how in the polygonal version of this landscape to turn off the background. There's nothing I can find in there that lets me do that and just retain the line. So I had to resort to going to the spherical option. Okay, so my version of the Spherical Horizon in Stellarium is in the home directory that I created. We go into here, you can see the horizon_backyard.txt file. That's the simple two-column arrangement of azimuth in degrees and altitude in degrees, 0 being due north, 90 being east, 180 being south, 270 being west, and that's all there is to it. So you just need to take enough data in here to properly capture the undulations of your particular horizon. Other than that, it's dead simple, right? Then we have the landscape.ini file, which you can open up in any text editor. And now we have the type is spherical. These are all name, author, description. Those are simple things you could probably leave out. The map text is now required, and that's transparent.png, and I'll show you how what I did to create that. The rest of this may not be required. For example, especially if it's transparent. If it's a true picture, then yes, there will be an upper bound and lower bound on the angles that are represented by your picture. But in my case, it's a transparent picture, and so it doesn't matter. So I could probably just leave these out. I could probably leave out all of this and everything would be just fine. And then we come into the Polygonal Horizon list, and that's the two-column list that we just looked at. Now, if you happen to be off in your north angle and it's not 0, this is the parameter you can use to kind of give a little offset to make the north of your horizon file the true north. And you can play with that. Now here it's 0. I could have left that out. Would have been okay. The Polygonal Horizon list mode, this is default. Azimuth in degrees, altitude in degrees. And then the horizon line color. This is where you can see that I set red equal to 0, green is full on, and blue is full on, which makes cyan. So that gives me the cyan color. Now let's go back and take a look at this transparent PNG. Now, if you're making a more complex horizon, this would actually be a picture file that represents a picture of your backyard. In my case, I'm not interested in that. I just want a horizon line, and then I want it to be transparent below that so that I can see the stars below. So let's just look at this file as a PNG. Very interesting, isn't it? I went into a simple paint program. You can use any one that you happen to have access to. But in my case, I used the one that came with Windows. And I think this might have been the first and only time I ever used this file. But it's Paint 3D, I believe is what it's called. Yes, Paint 3D. Create a new file. Then I'm going to come in and create a canvas. So canvas options. I'm going to use measurements in pixels. I don't want to lock aspect ratio. I'm going to set my own aspect ratio of 4096 by 1024. So a 4:1 aspect ratio. We're going to keep pixels here. Transparent canvas I want on. Now I'm just going to save this canvas as a file. And for example, I can save it into landscapes, whatever your directory is. In my case, it's home. And save it as transparent.png. Of course, I already have one in there, so there's no point in saving over it, and that's all there is to it. Now, when I implement that in the landscape.ini file, this is what I end up with. I end up with the cyan line representing the horizon. The image of the backyard is transparent, so as a result, it doesn't block any stars, so I can see that just fine. Now, once you go through all of that, come down to the configuration window and be sure and save your settings. And now let's take a look at a couple of other items. First of all, one of the things that we're going to be looking at as I slew over to a star that a target that I'm particularly interested in here, NGC 5906, for example. And now we'll turn on the ocular view, confirm that this is the Celestron C9.25. I have the camera rotation at minus 25 degrees. One of the things that I have done recently, I went back to some old photographs I had taken with my DSLR, did an image solve on it using PixInsight. It told me that the effective focal length was actually 2,220 millimeters, whereas the theoretical focal length is 2,350. So when I made that adjustment to this picture, it gave me a slightly longer focal length imaging system, and it brought this guide star, which was outside the view of my off-axis guider, it brought it into view. Now, another thing that I want to do to compensate for potential errors in setting up the camera and the off-axis guider rotation is I want to move this around a little bit from a framing perspective so that I can have a better chance of seeing this guide star, get it away from the edges, because I'm not sure how precisely I'm going to be able to locate that. Now, there's a couple of things going on here. First of all, there's a lot of extra stars in here. Let me show you where that comes from. Go back to the configuration window, go into extras, and then down here, if you take a look, in this case, this text down here says all available star catalogs have been installed. Now, if you haven't done that, there'll be a button down here saying 2 of 3 or 3 of 6 or something like that. Press the button, install the catalog. I went through that several times to get through all of the additional star catalogs and then install them. Of course, you'll have to get out of and then restart Stellarium when you do that. The next thing I did was to go back over to this area, go into the sky, and then I adjust the magnitude so I can see dimmer and dimmer stars down to whatever. Now, none of these at 19 they're probably not going to be good guide stars, but it's nice to know that the stars are there. You might well be able to see them in your guide star image. It's just that the signal to noise ratio is going to be so poor you're probably not going to want to use it as a guide star. But this is how you can bring in those stars. When you load in those extra stars from the additional star catalogs, go in here and raise the limiting magnitude so that those stars become visible. And then, of course, once again, you do make those changes, go back and save the settings again. Okay, so that's where these stars are coming from. These would not have been visible in the original installation of Stellarium. It's pulling these out because they are in those additional catalogs. Now, back to framing. One of the things that you notice with Stellarium is, and if you only get this information on the RA and the deck coordinates, for example, if you have something selected. So you've got to select a star. But what if the location, for instance here, is not on a star? How do you come up with the coordinates? Well, there's two ways. First of all, when you have the ocular viewport on, as I have here, the RA is written here and the deck is written down here. It's kind of faint, and I swear I've looked for a way to change this color so that it's more visible, but I can't find it. Sometimes also the RA overwrites some of this other information that's in here, and so things become a bit jumbled. And so now the question is, well, how can I get a more clear picture of where it is that my actual aim point is, because there's no actual star there. And in fact, that's what I get. When I don't have something selected and there's nothing to select right there in the center of the view, I have no information. Well, this is another useful plugin, and if you come down to the bottom, you can click on this icon, which is probably not going to be your setup if you haven't done this. And what it does, it turns on, notice that the RA and the deck are continuously changing as I move the mouse pointer over the image, which means all I have to do is plant the pointer right there at the center of the image, jot down the RA and the deck coordinates, and then that's what I can enter into my image planning software so that I know where the telescope should aim, so that it gives me a nice, comfortable error bar around the location of this guide star, if that's what I'm after. So that's one way of getting at a coordinate in Stellarium if you can't read this ocular view, or if you're not using this ocular view. It's nice to be able to go to some location and be able to say what are the coordinates at that point. Now, there's another thing here. Notice that this is reading out an RA declination. first of all, let's look at how we upload or download this plugin. We'll go back to the configuration, go back to plugins. If you scroll down here, you'll find pointer coordinates. Now, I've already installed it, obviously, but there'll be a button to install, and you can tell it, or maybe you just click this, load at startup. You'll have to get out of Stellarium, then get back in, and once you do that, you'll have access to the configuration window, and then you can say enable display of coordinates at startup, show plugin button on the toolbar. That's what I was just pressing. This gives you a selection of what coordinates you want, and this is where it's important to know if you're using image control software that wants coordinates in J2000 versus JNow. You need to select which one you want. For instance, I can use the right ascension declination in J2000, use JNow. There's other options here. For me, I'm using it to develop coordinates to put into the image planning software, so I want the J2000 version. You can change the font size, and you can also change the position. I think the default position is to put this up here in the upper right-hand corner, but unfortunately when I have the ocular view turned on, all this information tends to obscure what's being said here. So I moved it down into the right bottom corner of the screen for me. And so this is what I go with in my setup. So this, you can save settings here. That's fine. Go back to the main window. Once again, we've changed some settings, save the settings again, and then you're good to go. So this is how I pull out coordinates of a location where I can't actually select on a star, and it still gives me the ability to use Stellarium for image session planning when I have an off-axis guider. If you don't have an off-axis guider and you're using Nina, for example, it has a pretty slick interface for image planning or target framing, and I would just go ahead and use that if that's convenient for you, because it works pretty well and it's all part of the same package. But if you have an off-axis guider, and until Nina incorporates the image view of the off-axis guider, you may need to use some other resource, and Stellarium is a very good choice. Okay, guys, well, that's all from here. Just wanted to give a quick note on some of the things you can do in Stellarium, and I'll talk to you later. Take care.